Share screen. Shrink this. All right, naming the stars, mile markers of astronomical history. You might ask why anybody would want to do a program on stars, and it turns out that how stars have been named over time has an insightful history into the human fascination with the night sky. Indeed, the story of star nomenclature is an outline, in fact, of the evolution of astronomy, and knowledge of it adds to one's skill as a sky watcher. For me, if I'm interested in the topic, the best way to learn it and absorb it is to study it and then make a presentation on it. So hence this presentation. Now, in addition to being a humble sort of amateur astronomer, I consider myself a bit of an amateur anthropologist as well. I'm not claiming to be a polymath or anything, just more like a broad spectrum dilettante. But at any rate, this topic, naming stars, intersects, in my view, between those two interests, astronomy and anthropology. You see, once you postulate that humanity evolved rather than being created whole cloth in an instant, the question immediately arises, as of course we all know it has, what is the essential characteristic that separates humanity in that evolutionary process from the other animals? At what point, in other words, in the evolutionary process can we say our ancestors crossed a line from hominid to human? It was once postulated that line was marked by the use of tools, but we now know that that's not true. A lot of animals use and create tools. Well, then it was thought that it was language, but that also has proven to be false. So my humble little theory here is I postulate our ancestors became human when they started naming the stars. You see, other animals are aware, observe, and respond to their environment. The South African dung beetle, for example, has been demonstrated to be able to see and navigate by the Milky Way. They actually put little hoods on them and studied their movements to establish that. Interesting little study. But I'm pretty sure that the South African dung beetle has no curiosity about the Milky Way. What is unique about humans is the quest not just to observe and experience the environment, but to understand everything. And a mind that starts naming stars is a mind on a quest to understand them. So I think it makes a pretty good demarcation. Nobody's come up with anything better. Now, whether you buy my proposition that naming stars is the defining characteristic of humanity or not, I think it is undeniable that all our human ancestors have named stars. And I'm pretty sure that no one is ever going to be able to prove any other species on this planet, at least, has done so. For the purpose of this talk, then, we're going to accept my theory that this is true because it makes the talk more important, if nothing else. All right. Now, I got to have well, I didn't move my slide, so I just finished that slide too. So in passing, I just want to, I can't help but note that everything that has brought us the great power to alter our environment, this curiosity has. Unfortunately, the wisdom to use that power without destroying the environment has not evolved apace with it. As I think this illustration of the growth in light pollution from the 50s into now and projected into the future illustrates, and it's illustrative of a bigger problem we humans have, but that's a digression. So let's move back to the subject at hand in a more direct way. So now, if you are a novice observer, you're probably going to immediately understand or appreciate the point I'm trying to make with this slide. If you're an experienced observer, I ask you to hearken back to the days when you first looked at a sky chart similar to this. And if your experience was anything like mine, it was a mixture of curiosity on the one hand, the pull of curiosity, and the push of intimidation. You could look at all this, and you might spend a minute and start to figure out some things about it. But pretty soon you say, well, what are these M things with numbers? And what are all these weird symbols? If you momentarily postulate that must be some kind of naming system for stars, you'll be confused by the fact that you see the same symbols on different stars. That doesn't make any sense. So, you know, you look at that a minute and you might say maybe the lawn needs mowing rather than bend your brain anymore trying to figure that out. But if you spend a little time and a little bit of study, you come to realize that it's far worse than that chart implies. This is a slide that gives us a list of all of Sirius's, the brightest star in the sky, all its monikers, all its labels, names, 63 of them. And this is not unique to Sirius. Most stars will have very nearly this number of as I say, monikers. Now, how in the world and why would you have so many names for a star? How did this come about? Well, it's a consequence of basically two things. First of all, you're naming stars, you're in essence cataloging them, aren't you? And over time, the people cataloging stars initially just their interest was such that they cataloged more and more stars with each passing attempt at it. We go through Hipparchus is the first to put together a catalog of stars, 850. But then subsequent people, Ptolemy and Ulebeg and Tycho Brahe, who we'll talk about, and John Flamstein will visit about some of these in their work, catalog more and more stars. And every time you made a new catalog, well, you had to assign, and they cataloged them different ways. You had to assign different monikers or different names to them. And then, of course, the telescope came along and opened a much deeper view. Lots more stars could be seen. And this thing has progressed along with the technology all the way up through, you know, Tycho with a satellite, and that has cataloged enormous numbers of stars. So each of these catalogs is generated. And then there's another factor, and that is as we learned about stars, we began to figure out how to measure different aspects of them. Spectrum, proper motion, whether they were double or not, whether they were variable or not, and so forth. And all of these brought about catalogs of their own. So that's in a nutshell how we've come about having all these different names. But before we get further into these catalog processes, let's start and back up and recognize that proper names, that some of the brightest stars have proper names, and every civilization, by my definition of humanity, has probably named stars going all the way back. So Sirius has had an unknown number, being the brightest star in the sky, undoubtedly been not had a name, but any civilization that could see it. And so it's probably had more proper names than there are visible stars to the naked eye in the sky. We don't, of course, have a record of all these names, but we have a few, and this just illustrates a handful of the known names that Sirius has had in different times frames in different civilizations. Cirrus, the word Cirrus we use today for it, for its name, is derived from the Greek word for scorching, which you can understand why that would be fitting for the brightest star in the sky. The Egyptians referred to it as Saltdet, if I probably pronounced that wrong. Who was a goddess of the fertility of their soil, and the connection here is that Sirius would rise in the east just before the Nile would rise each year and bring fertility to the Nile Valley. And you can just go down this list and see that there have been a lot of names. Dog star is interesting how frequently that shows up. The Chinese call it the celestial wolf. The Romans called it canicula, the little dog, and the American Indian tribes in their own language typically referred to it as the dog star. And I'm not sure that I can entirely understand why that's common across civilizations. Now, what we're going to learn is that most star names come from some characteristic of the star, either in terms of an inherent characteristic, such as its brightness in the case of Sirius, or the color in the case of Antares, which means rival of Mars, or the variability, the demon star, Algol, or its location, as in the case of Aldebaran, the follower, because it follows the Pleiades, or in its location in a constellation such as Rigel, which means the leg of Orion, or Deneb, which means tail. A lot of Denebs, by the way, in the sky. Function. Some stars were named like Capella, which finds a she-goat, based upon the season in which they were up. In this case, as I understand it, aligned with the period of time when the shepherds would sleep with their flocks in the field. And a few are named after people. Cora Caroli stands for the heart of Charles. Charles II, this name was given to the star by Newton. A new constellation had been created. They were filling the stars out in these constellations. And so he had that opportunity. Bernard stars, named after the fellow that discovered proper motion, and that the star that he did that with just carries his name. And strangely, Canopus, I don't know, I have not found why this is the case, but King Malenus' fleet navigators named after that star, or vice versa. You never know. That may be that the Iliad was written, used the star's name. So, so this is the mechanics about how this, and it's really fascinating, about how these names came to us. You may know that most of the star names are Arabic. So, as I mentioned, Hipparchus in about 129 BCE compiled the first known catalog of stars. And he invented the magnitude system, by the way. And he made a catalog of 850 stars in 48 constellations. And the ancients did not map the whole sky with constellations. They were just important parts of this, like the zodiac and so forth, the polar region and so forth, that they had their figures in the sky in their imaginations. So that's what he used. He did the 850 stars, and he measured their positions with the exactness. He had a globe of the sky made. He was quite a scientist, and I found this interesting, particularly interesting. And when you think about it, it makes a lot of sense. I always wondered how these guys could visually estimate. And he created, as I say, he created a magnitude system from first magnitude all the way to sixth magnitude, the concept of it, and assigned the magnitudes to stars. How could you do that with the naked eye? How could you judge the brightness of stars and compare them in that way? Well, it turns out, of course, when they don't know what a star is, right? And it turns out the word magnitude refers to size. And when you think about it, brighter stars appear bigger. And for all they knew, all the stars were the same distance away. Some might just be bigger than others. But at any rate, that's what he did. He was measuring, he was judging them based upon, probably based upon their size, given that he assigned the term magnitude to them. So anyway, Ptolemy comes along about 300 years later, and he's very interested in the sky. It was a common fascination for a lot of reasons in these periods, because people intuitively understood that those stars and the night sky had to be important and be tied into important things, and they were particularly interested in position more than they were anything else. But frankly, they couldn't measure much of anything else anyway. So he cataloged 122 stars, including the 850 that Hipparchus had cataloged. He was aware of Hipparchus's catalog, and in fact, he compared his measurements, and he explored the concept of proper motion. Now, his catalog of 122 stars was just a tiny part of the work. It was an 8-book project altogether, with a lot of the math involved in astronomy at the time, and analysis of that, and so forth. I don't remember the titles of each book or its purpose, but the catalog was just a small element that was essential to it, but not the whole thing. And this is called the Almagest, and it was translated into Arabic in the 8th and 9th centuries by Arab scholars. This would have been during the Middle Ages, when science sort of went into a lull in Europe. But the Arabs had a scientific renaissance of their own during that period of time, and they were aware of Ptolemy's catalog, who, by the way, was a Greek Egyptian. They lived in Alexandria. Ptolemy did. So they translated it, and then later in Europe, it was the Arab translation was then translated into Latin, and because Ptolemy was not giving, he didn't have names for 1,000 stars, and he wasn't in the business of giving them names. So the way he identified them was to refer to where they were in relation to the constellation they were in, the same 48 constellations that Hipparchus was using. So, for example, you get the tail star in Eridanus, Ptolemy's river in becomes Acura in Nahar, if I'm stumbling over it, in Arabic translation. And then when that is Latinized in the 12th century, it becomes Akmar. So this is how we've gotten these Arabic names. The Arabs simply translated Ptolemy's Greek description of the location in the constellations, and then those were then later Latinized, and you end up with what amounts to Arabic root names rooted in Arabic. So just a few examples here in Arcturus. Chi Arcturus is Setula, which means a water jar, and Theta is Anka, which means hip bone, and so you can see how that fits into the constellation. and delta is scat, which means shin. And on the left is a chart that just a small clip of a website, which the title of the URL is there at the top, that goes through and interprets all these names for you if you're interested. It's fascinating, but that's how this came about. Now, we turn now to an interesting character, Tycho Brahe. And let me get my notes and make sure I don't skip anything that I want to talk about here. So when Copernicus writes his tome on celestial mechanics and his theory about the layout of the universe and the solar system, he's actually using Ptolemy's catalog. So Ptolemy's catalog was in use for like 1,600 years until we get to the late 16th century, middle to late 16th century, and Tycho, who is not probably as much of a popular figure as he probably ought to be in terms of the importance of his work. He was a noble. A lot of these people are either priests or nobles that early science. They've got the time to devote to their esoteric studies. His father wanted him to be a lawyer. He was supposed to be studying law, but along the way, he fell in love with astronomy. And part of how that happened, there was a partial solar eclipse that was predicted, and he witnessed that. It caught his fancy, and he became interested in this whole idea because there were ephemera at the time, and they weren't very accurate. And there was a constellation of Jupiter and Saturn where he got his hands on all the information he could about the predicted conjunction of those two planets, and all of them were grossly in error, some by several days. And so he got this bee in his bonnet. He got into astronomy. He would do his astronomy at night. He had a tutor. When his tutor would sleep, he would do his astronomy. And he ultimately abandoned the law and became full-time into astronomy. And he set out to measure, his original goal was to measure the orbits of the planets in great detail, because he was convinced that only by careful measurement of their motions in the sky over a prolonged period of time could we finally really figure out how things worked. At the time they had these theories. The Aristotelian theories were that the planets were on epicycles, and they went around, and that explained the periods of time when they seemed to go backwards and so forth, and that all the stars were fixed and totally unchanging. Beyond anything beyond the planet and the moons was utterly and completely fixed, and nothing ever new. It's always a steady state concept of the universe. And Tycho, doing his work, discovered a supernova, and he documented thoroughly that it was not a comet or any other explanation, that it was in fact a new star, and that exploded this whole Aristotelian finally. So he's a central figure in the Renaissance of astronomy. His catalog goes on. One of his assistants was Kepler, and Kepler took his measurements and worked out his laws of planetary motion. But getting back to catalogs and star names, I've digressed grossly here. All of that is to bring us to Uranometria and Johann Bayer's Uranometria. So here he is in Tycho's time. Tycho has measured all these stars. Tycho put them in a catalog, but Bayer wanted to publish a chart or charts, and he was felt the need to somehow title or name these stars, and to be able to do so in ways that everybody who was interested in them could share the same names. And so what he did was in the and he cataloged 1,200 stars. He came up with this theory or this concept where he would use the Greek letters to name the stars in each constellation, starting with Alpha as the brightest star and Beta with the next brightest, and so forth, going down by order of magnitude through the Greek letters. And then when he ran out of Greek letters, I mean, we got 1,200 stars here. They're divided up into a number of constellations, I think 60, as he added 12 new southern ones. He would run out of Greek letters, so he used capital Roman letters next, and then he used lowercase Roman letters. And this became the chart for and catalog of star positions and star names for a considerable period of time until we come to Flamstein's catalog in 1725. Now, here's the thing. He was the Astronomer Royal in Britain. His problem with Bayer's concept, besides the fact that he wanted to do more stars, and so therefore he had to have his own catalog, was that it was just from a technical standpoint, it was objectively difficult to rank stars by their brightness as you got dimmer. It became an increasing challenge to discern which star was brighter than what star. It was really a cumbersome process and very difficult and ambiguous. And so he came up with an alternative concept, and that was he would just start numbering them from west to east. And he did that for each constellation. That became the Flamstein system. Now, interestingly, Newton and I think Halley published his catalog before he wanted it published. And he actually went out and bought up like 300 copies, if my memory serves, of what they had printed up of his catalog. And when he actually did publish his catalog, he didn't put the numbers in. A French astronomer came along and put the numbers back in that Newton and that Newton's publication had included. So at any rate, after this point in time, now we've got the Bayer system, and now we've got a Flamstein system. So what happens is that the Bayer system, insofar as it uses Roman numbers, fades away. But the Greek letter system, which covers the very brightest stars in each constellation, remained in use. And Flamstein's naming system became the means for labeling stars that didn't qualify for the Greek letters in the Bayer system. So now you got proper names. You've got proper names from the process I described earlier for like 1,200 star, 1,022 stars. You've got the Greek letter system, and you've got the Flamstein system. Now, of course, as I say, along comes the telescope, right? And indeed, with the glass, Galileo quote here on the right from Galileo 1610. Indeed, with the glass, you will detect below stars of the sixth magnitude such a crowd of others that escape natural sight that is hardly believable. The largest of these we may designate as of the seventh magnitude. So here in 1610 is the first indication that the magnitude system is going to go beyond what Hipparchus and Ptolemy had used. And on the left side, is interesting that this bezel is noting that certain stars are wobbling in place, and he concludes they've got to have companions, even though you can't see them. And he said he notes we have no reason to suppose that luminosity is a necessary property of cosmological bodies. The visibility of countless stars is no argument against the invisibility of countless other ones. So I just got that caught my attention. But the bottom line about all this is the telescope comes along, and all of a sudden our catalogs are going to start exploding, right? And that happens with the Bonner Durchmunsterung survey that is begun in 1859 by F.W.A. Arglander at the Bonn Observatory. He's got a 78 millimeter refractor, so you're talking about 3-inch telescope, and he sets out to catalog and measure estimate the magnitude and measure the position of every star that he can see with that telescope, which basically goes down to 9.5 magnitude and consists of 324,188 stars. Dedication and focus is a big part of becoming famous in anything, I think. Dedication and focus. Think about that. Now, he actually had assistants that did a lot of that work. And what they would do is they would start in 1 degree bands. So his naming system is 1, 2, 3, 4, 5, 6, and so forth through I think it's 1 degree bands, and he did that all the way down to -1 degree declination, and then they supplemented that to get southern stars with a catalog that's abbreviates as SBD, Southern Bonner Durchmunsterung, which went down to -23 degrees and added another 34,000 stars almost. And then another survey done even further south that added over 600,000 stars for a total of 1,071,800 stars. And these stars, the catalogs for these are a DM, the letters capital DM, and then a number, and that number is as I said, west to east within these 1 degree bands. So Vega is BD plus 38. That means it lies between 37 and 38 degrees north, and it's the 3,238 star going from west to east. So now we've got these historic catalogs in place with over 1 million stars, but there's more. As I indicated earlier, part of this explosion in star names come from the technology, being able to see, but the other part is learning about them, and then you want to catalog them by their characteristics. And so you need names for these stars. So variable stars, for example. In variable stars, Bayer's Greek letter remains in use for those stars that have Greek letter names. But then you start using capital Roman letters starting with R. And the 2 letters, and then once you run out of single letters, R, S, T, U, V, W, X, Y, Z, then you go back to 2 letters starting with R, 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 S, etc. And after you run out of that, you start with double Z. It doubles back. After you've gotten to double Z, you double back to A, B, etc., omitting J. And then after AZ, the letter V and a number. So V335 is the 335th brightest variable in the constellation that you're referring to. In all of these cases, this is tied to the constellation. So it's R Cygnus or RR Cygnus, etc. just like the Bayer numbers, which are linked to constellations, and the Flamstein numbers, which are linked to constellations. So then you got supernovas. So each year, the names for supernovas are SN, followed by the year of discovery, followed by the next available capital letter for that year. Then two lowercase letters in order of AA, AB, etc. Double stars, you use a subscript. In the early days, you had two really close stars. They would just assign a subscript of 1 or 2, with the 1 being assigned to the western component and 2 to the easternmost, rather than the brightness. More common is the use of A, B, C in the modern situation. So you've got let's see, Sirius is a multiple star. So you got Sirius A and Sirius B, and I think there's also a Sirius C. And then you have your catalog designations that I've been referring to. A prefix like the DM that I mentioned earlier, designation for the catalog, and whatever system is using to ID each star in the catalog, usually keyed on its coordinates in some way. So what are some of the specialized catalogs that have given stars names? Well, spectroscopic classification, the Henry Draper catalog. You'll see these when you go into any kind of database kind of system. You'll run into these names that I'm visiting with you about. The BDs and the HD here, and the Bayer system. You'll see these listed for the stars if you click on them. And the Henry Draper catalog was, I believe, the first big catalog to come out and catalog stars by their spectral type when they learned how to do spectrum. And then it grew over time, and so you got these extensions you can see there in the slide. Double stars are now cataloged. There have been a lot of historic catalogs. BDS for Burnham's, ADS for Aitken. These were people who were early pioneers in studying of double stars, but today they're all in the Washington Double Star Catalog, which has a huge amount of information on each star, including, I think, their Flamstein numbers and so forth. And that catalog, by the way, is updated every night. So as additional information comes in, they update that catalog. And then you have proper motion catalogs and carbon star catalogs and so forth. So basically, this catalog thing has exploded into a near approaching infinity, particularly now with Hipparchus, Tycho, satellites that are doing astrometry of stars in huge volumes. So here's a summary of star nomenclature, because we've gone through a lot. You've probably gotten confused. For some stars, and not a great many, there are recognized proper names. Most of Ptolemy's, the names that came, the proper names that came out of Ptolemy's catalog, are not recognized nor in use. Proper names are really only for the brightest stars in terms of common use. If you looked up, if you refer to a star, if it's a Sirius or a Vega or something like that, that's how it's going to be referred to. But otherwise, going down in magnitude, Bayer is what you're going to see next. And then if you get dimmer than the Greek letters, you're going to see the Flamstein numbers. And if you get beyond the 1200 or 2900 stars that Flamstein catalog, you're going to see the DM numbers as the primary way of naming or referring to a particular star. But in these catalogs, these digital catalogs, you'll probably see all these. They'll give you all these. Draper, the HD number, Bright Star catalog. The Bright Star catalog is comes with an HR and a number, and this is all this is originally the Harvard catalog, if I remember correctly. Then it became the Yale Bright Star catalog. Now it's just called the Bright Star catalog. and it is limited to the stars that are presumably visually observable to the naked eye. And so it's got about 6,000 stars in it, and about everything that you might think to put in a catalog about a star is in there. So they're quite a comprehensive spectral type, proper motion, so forth and so on. Then you've got the Smithsonian Catalog, SAO, and it goes down to 9.5 magnitude, and it's also quite comprehensive. And they are, the names there are similar to the German catalog, the Deutschlandstrunger, in that it has it works off of right ascension and declination bands as to how they line them up. It's in order of right ascension in each declination band. So like here you got, I'm referring to here, 18 would mean 18 degrees north, and then you have a west to east number. And then the Washington catalog uses a J plus 5 digits for the right ascension of the star and 4 digits for its declination. So they just literally use the coordinate for the star as the name of the star. And then you've got Hipparchus, you'll see that as HIP and a number, which is also right ascension derived. So finally, and by the way, in these Tycho catalogs and Hipparchus catalog, you're talking, I misplaced my notes here. I'm not going to take the time to dig it out, but you're talking over 1 million stars. Let's see. Well, it's a lot of stars that they have documented down to thousands of them of a minute in accuracy. It's the latest stuff, and they use these catalogs for navigating satellites and so forth. So finally, so we've sort of walked our way through this whole thing, but then in 2016, the International Astronomical Union, which is responsible for you can't buy a star name, by the way. If you run into that on the internet, it's a fraud. Responsible for the official monikers and keeping up with how stars are named and referred to, decided that we need to go back and tap some of the other civilizations and add star names from other civilizations to the official list of stars with proper names. And so they, from Aboriginal Australians and Chinese, and Coptics and Hindus and Mayans, Polynesians and South Africans and American Indians, they gathered stars. Last I was able to find a number for 330 stars. And this website up here, you can find those, by the way. So a total of 330 stars have recognized proper names that, by the International Astronomical Union. And that is my talk. Any questions? I'm going to stop share. I appreciate you guys sticking with me.
That was very interesting.
Maybe
I had a hard time hearing it.
Maybe more than you wanted to know about naming stars.
You know, I think on Double Star catalog, John Herschel did like 850, 480, 800. He did a large number of double stars that he recorded the positions and everything. I'm sorry, guys.
That's all right.
That's why I had it on mute and everything for the hour and a half.
I understand. All right. No questions. Man, I covered it all, did I? I can't hear you, Jeff.
I have to unplug my headphones to be heard. Can you hear me now?
Yeah.
Yeah, but I can't hear you, so that's the problem. At any rate, my take on it is I kind of like Hipparchus the best, and then, just right ascension and declination after that. It seems to me like, and then we've got all these traditional proper names, which seem to work pretty well.
Yeah, the only drawback to the right ascension declination is, of course, they change. And that's the reason that J number is in the Washington double star catalog. It refers to the epoch which those numbers work, if I appreciate it correctly. All right, guys. Thanks for tuning in. Were you able to, you Jeff, you said you had a hard time hearing it, and so did Rocky. I hope the audio was good enough that the
I heard
can,
it loud and
I can
clear.
hear you fine when I have headphones in, but I can't hear you without the headphones.
Oh,
And then I can't speak to you when my headphones are in.
I got you. All right. Good night, guys.
Good night.
Thanks.
Thank
Bye,
you.
Chris, Sean.